Hi friends, welcome to follow up. Let's have a look at problem 1048, longest string chain. In this video, we're going to explain a solution based on dynamic programming. So here we are given an array of words where each word consists of lowercase English letters. So in this problem, it's defined a relation called predecessor. So basically it says that word A is a predecessor of word B if and only if we can insert exactly one letter in A to form word B. So here is an example. For example, ABC is a predecessor for ABAC, right? So you can regard it that we added an A here, right? So a word chain basically is a sequence of words where each word in previous is the follow-up words. They form a predecessor relation, right? So we want to find the length of the longest possible word chain with words chosen from a given list of words. So here we have three examples. In the first example, we get an output 4. So here is one of the available chains. So notice that the longest chains might not be unique. However, the longest length is unique, right? For example, for this example 1, we can have several different chains, right? For example, we listed 2 here. So in the second example, actually the whole list, actually after rearrangement, you can regard it as a chain. For example, you start from XB, right? Then you get XBC, then you get CXBC, then you get this one, and then this one, right? So in example 3, so it's very special. The output is 1 because a single word, by definition, is also a valid chain. So in this problem, the constraints are the following. First, the length is at most 1000, and each word has length upper bounded by 16, and the words consist of lowercase English letters. So with that said, we are ready to do the analysis and do the coding part. So here our strategy will be dynamic programming. So here I'm going to use a dictionary to store the information. So here we store word and length. And basically this pair means the longest chain length ending at the word, right? So the main idea is here is how to update the DP table. For example, if we have an ABC, right? So we can delete a C. We know that if previously we have a chain ending at AB, so we can increment that length by 1 to get ABC. So this is basically the thought. So you can look at the analysis for exercise 1 and exercise 2 for this procedure. So I guess for this problem, the coding speaks itself. So let's do the coding. So basically, I'm going to split into 3 steps. So step 1, so I'm going to make some preparations. So here I'm going to use a DP, and then the word and length. So here basically for word in words. So initially we use this initialization, meaning that each word is a valid chain, right? Ending at itself and beginning at itself. So this is the first step. So next we want to do update. So for this we need to pay attention to the order. So pay attention to the order. For this for this purpose, I'm going to do this for word in sorted word. So we are going to sort the word with respect to the length, right? In other words, shorter word at the beginning. So this way we can consistently check the update. So let's see, check possible update. So we want to check if we can update the DP information for chain ending at the current word we are looping for, right? So basically, how do we do this check? Basically, we want to delete one position in the current word we are looping for, and to check if the resulted word is inside the DP table or inside the word list. If so, we are going to do the update. So for I in range length this word. So the new word will be the following. Let's use predecessor. It's just for indicating this might be possible one, right? So this is up to index I, not including. But here we start I plus 1 onwards, right? So this predicts pred corresponding to delete one character at index I from word, right? So what we want to do is to check if pred in and dp, right? So we can check if pred in word list, but this is a list. So here dp contains all the words, right? So unique words. So we can do this check. This is more efficient. Then we're going to update if after deleting one word is still in the dp table. At least we can do this. So this, because we want to find the longest, we use max function. Then we have dp pred plus 1. In other words, the longest length of chains ending at the current word is at least as large as dp pred plus 1, because we can the pred is the predecessor for the current word, right? So this finishes the update. So actually the next step will be return. So we want to return the maximum values, right? Return dp values, the max. So let's I guess for now we finish the coding part. So before we make any comments, let's first do a test. Dict has no attribute value, so here is values. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So here for demonstration, so you can print out this print the dp table status after we finish the update. So you will get something like this. Basically, it interprets like this. So the longest chain ending at word A is 1. Ending at word B is also 1. Ending at BA is 2. So you can actually get the chains. For example, A to BA and B to BA are the two valid chains. And the ending at BCA is 3. Let me point to you one. So BCA, right? If we delete C, we get BA. If we delete B, we get A. If we delete A, we get B, right? There are two we found, we spot. So similarly, you can see the longest chain ending at BDA is also 3. So you can delete B to get BA. Then you can delete either A or B to get B or A, respectively. So the longest chain ending at BDCA is 4. So for example, from BDCA, you can delete D, you get BCA. But we know from BCA we have we can either run BA and then A, or BA and B. So that's basically about it for this problem. But the speciality for this problem is that this is a little bit different from the typical tabulation, right? We used a list or DP table. So here we are using dictionary. So essentially they are the same thing, but here we want to point out and that it's important to pay attention to the formality sometimes. So with that said, that's about it for this video. Thank you.